Hello everybody. Today we're going to talk about random number generation, which I've already got a video lecture over that, but we're going to get into a few more details here. Now, whenever you're dealing with random number generation, in Python, you first import random. And then to get a random integer, if that's what you're looking for, you just make a variable and it's going to be random randint, and then the range, 50 to 100 or 1 to 12, 2 to 12, let's say. And it should give you a random number between those two ranges, as you can see. And I can use this a couple more times just to make sure it works. Here we go. You see? Now, since at this point we've gone over functions and things like that, it might be a good idea to make a method or function that'll give us a random number on its own. Now, def just print dice, let's say, and I'm going to give it the range. We'll call it low range, comma, high range, or let's just call it low high. We don't need to write so much. There we go. So all this has to do is essentially this. You can cut it, paste it, and it's just going to be low high. Perfect. And if I wanted to just print this, that's not a problem. Print the random number is, comma, random. And then I can just run that method in this case. Print dice. We'll go 2, comma, 12. So now I can run this. And it should roughly get me the, a crash because I did something wrong. Let's see what that was. Unbound local. Random, and yep. Let's go ahead and just make that dice, I suppose. See if that doesn't fix our problem. I can, there we go. Run, and we got 11. I'll run it again. And you see it's going to run the gamut between 2 and 12. Now all I have to do is just, I want an attack between 100 and 245. Run. And it's going to give me a number between that and that. Now, the downside to this is it's only going to be able to print it. What if I want that number back for any particular reason? Well, give dice maybe. Again, low, high. Same thing. In fact, it's exactly the same code, except instead of this, I return. And now, let's go with print. The dice roll rule is give dice 2, comma 12. So now I've got 2. One that prints and one that returns it back. So in this case, I probably want this to be a variable instead of just printing it. So var equals. And then I can print. Like that. Then I actually save that value somewhere else. We talked about global and local variables before. This allows me to actually save that variable from that function. And then I can do whatever I want with it. If I need to check it against another dice or use it to move a piece across the board or something, that's essentially what I would do with this. I can pass the values I need, it'll plug in, and this right here just stays the same, it doesn't need to change. And then I can compare if statements. Check this dice or another dice. Roll another dice. Pair 2. Now, oftentimes people will put this in a print statement, print the dice is, let's say, like I did a second ago, and that's fine if all you're going to do, 2, 12, like that, if all you're going to do is print it. But sometimes people will print it, and then you need to actually check it. You need to see what that value is. Well, the only time this gets a value is when it's run. So if I do it this way, and then I do it again, let's go ahead and grab you, cut, paste. This value and that value are going to be different. It's going to run it once every single time. So my first value and the second value are going to be different. So every time you run this, it gives you a different value. So just keep that in mind. If you print, this person rolled this dice, and then you go here and you do a variable for that, that and that are not the same. Just a little example of that. Now, of course, this isn't the best way to deal with dice, in particular because, well, it's not mathematically sound. When you roll a dice, if you wanted to go with actual dice percentages, when I roll a 2, for example, that is the least likely thing to roll when I roll the dice. That and 12. Because there's only one possible combination that gets you that. To get 7, there's like 6 or so possible combinations to get that. So statistically, this actually does not run the way dice are supposed to run. You have the same chance to get 12 as you do to get 2. Now, if I wanted this to be proper, and I mean, like work the way it's supposed to work, then what I would need, let's just say, I'll just call it proper dice, low, comma, high. Well, actually, this one, I'm going to make sure it's proper dice. So I don't necessarily have to give it a 2 or anything. What I need for this is 2 random numbers generators. And actually, I could use what I've already built here for this if I want. So I've already got one, so might as well use it. So proper dice, I'll just call it dice equals give dice 1, 6 plus give dice 1, 6. There we go, proper dice. Just gonna put some quotes around that, and there we go. I'll just do it like that. All right, this will give you proper dice, and I'll explain why. None. Oh no. What have I done? Let's see. Oh. I didn't return. That's why. Return dice. And you'll see I still get numbers. 5, 8, 10, 5. Now note that I'm getting lots of 5s and 6s and 8s. That's because with proper dice, those are the things that are actually going to roll the most. Theoretically, 7 should roll the most. 6, 7, 8 are the most rolled numbers, as you can see. So I should see those more than anything. Now the reason this is proper dice compared to that is this gives me a number between 2 and 12. And you have the same probability to get 2 as you have to get 7, 8, 9. This gives me 2 numbers, 1 to 6, 1 to 6. Essentially, I'm rolling 2 dice, and when I'm rolling 1 dice, I have the same probability to get every number on the thing, on each face. I can get a 1, 6, there's the same probability. But if I'm rolling 2 dice, the probability of getting a certain number combination, that changes things. So in this case, this right here will give you the mathematical proper way to get actual dice rolls. And that's something all these games and things have to take into account. Otherwise, it's not anywhere near as, it doesn't follow the dice rules like it's supposed to. Well, anyway, that is your quick rundown of random number generation using methods or functions with them, and how to get proper actual dice rolls.